So, my name's Kevin Wilson. I'm the orthodontic laboratory manager here at Dundee Dental Hospital and School. We produce a variety of fixed and removable orthodontic appliances for the patients of the orthodontic department. We also produce quite a few other appliances for different departments throughout the building. We're changing the way we're working, moving over to a digital pathway. We can now accept intraoral scans from the clinical area. These are then sort of worked on and built upon on the computers in the lab and then transferred into our 3D printer, and we can produce a resin model. So we're feeling this is the way things are going, this is the way the technology is going. We're hoping that this will cut down on their carbon footprint, provide less visits for the patients. There are certain pieces of treatment and for appliances made within the laboratory where when it's done the old way, patients would have to come back and forward for different visits, but doing it digitally, it cuts out a few visits. Certain pieces of work are solely digital, solely done on the computer, and we don't need the models. Going forward, we're hoping to be able to print from the 3D printer appliances which can then be put directly into the patient's mouth. So then we don't need an actual physical model to manufacture anything on. The manufacturing can be done with the printer with biocompatible materials. So that's the way it's all going. As I say, it's hopefully a big improvement on what we were doing before. Sustainability, as we've mentioned, the carbon footprint, and also the health and safety of the technicians working in laboratories. So for this, it's done, we can produce this model from a plastic model by scanning the model, or from a direct scan from the mouth. So if we've scanned the plastic model, we then cut back on storage. We don't need to have as much storage space because everything's stored electronically. And see, the amount of material that's used here to produce this is a lot in comparison to the plastic one, to the 3D printed resin model. The advantage is, I mean, that's been trimmed up already, so before it's trimmed it has to be bigger still, so there's material to trim away. We can make these hollow, whereas the printed ones are hollow. So yeah, it cuts back on material, and our actual material costs 25 kilos of a dental stone material. It's probably around about, in fact I think it's more expensive than a kilo of the resin. But when we're printing, our software can actually tell us how much resin we're using per model, and it's, I think we're sometimes about 10 millilitres. So we're getting quite a lot out of a kilo of resin. 3D printed resin comes in a bottle like so. 1 kilo of resin, as I said, the resin model uses about 10-15 millilitres of resin. In comparison to our Cristical, which is the yellow model, and that comes in 25 kilo bags. So there's a lot of waste with that. More transportation costs, as it's heavier vehicles for transporting it, larger carbon footprint, manufacturing processes quite laborious as well. It's got to be mined, the material, so really not very nice. There's silica within it as well, which is really fine particles. So there's respirable crystalline silica. So as I was saying earlier as well about the health and safety side of things, it's better for the staff in here. Can also cause reactions with their skin and eczema or other allergies. Contact dermatitis and such like as well. So to finish that type of material, large machine like this has to be used, so it uses quite a lot of power to turn the motor, a lot of water, the water's constantly running whilst the machine's running. So if we have a lot of models to be done, then they have to be trimmed on here, and it could be running for hours. So the amount of water going down the drain, down the sink, along with a lot of sludge and slurry coming out of the machine, then going into the sink. So the carbon footprint, or the environmental effect of using so much water isn't so good. We also then have to have our estates colleagues come in and clean out the catch pot underneath, and that's got to be disposed of. And then at the end of the day, when it comes to disposing of this sort of material, it has to go through a specific waste stream. So it's not just going into household waste and into landfill. It has to be incinerated so that it's safer for the environment. So yeah, we cut back on electricity usage, because these big, strong, powerful motor in at the back of this machine to turn the two wheels and to give it enough torque so that when you're pressing against the wheel, that it's going to keep moving and keep cutting, in comparison to the more modern digital technology where you have simpler motors using less energy, LCD lights to cure the material, and just a bit more economical on power. So the environmental impact, there isn't any really sort of evidence to prove that going digital is any better than the old way of working through the whole life cycle of manufacturing the materials to disposal. At least at the moment, we know we're using less materials, we know we're cutting down on transportation costs, and then the new models are all going away to the patients, and we're cutting down on storage space.